Now, in this part of the lesson, we'll look at another model that applies the concepts of linear algebra that we learned in the first part of this course. And here we have the input-output model. Now, this guy on your on the left is Vasily Leontief, who pioneered the development of this input-output model. Now, this is not only theoretical because uh, we also we also use this input-output analysis. Okay, so for example, Philippine Statistics Authority (PSA) collects information in the input-output accounts of the country. Okay, so it's a publication. So it's used in real life, so to speak. Now, the model assumes an economy that's made up of primary inputs, the sectors that produces, and final demand. So in this case, when the primary inputs are labor capital, okay, so you have machines and workers that that are inputs to production, and then they are used by the producing sectors. For example, agriculture, manufacturing, mining, and so on and so forth. Okay, so this sectors produces output that will be used by themselves, by the other sectors or themselves. For example, agriculture produces seeds that will be used for replanting. So the output of seeds are used in agriculture, but some outputs in agriculture are used, for example, in the manufacturing sector. For instance, in the manufacture of foodstuff, right? So if you have corn in the agricultural sector, the manufacturing sector would use those corn to produce cornflakes, for example. Okay, so some of the output are used within the different sectors, and also the output are also used by um, final demand entities. Okay, so for example, government can use the outputs in the producing sector. For example, in agriculture, they can buy rice, for example, and households will also consume whatever's produced in the sectors, and the rest of the world through exports. Okay, so we have inputs, we have the sectors that produce output using the inputs, and the outputs will be used either by the different sectors themselves or by household, the government, and the rest of the world through exports, which constitute the sectors of final demand. Now, in this model, the usual starting point is the transactions table or the input output table. Okay, this input and output table describes the flow of products in the different sectors of the economy, right? Both the producing and the consuming sectors. And usually, this is constructed for a particular area. Mostly in the Philippines, it's constructed for the whole country. And so, in this model, flows between industry or between consumers and producers are usually measured for a particular time period, usually a year. Okay, and this is in peso terms, so it's monetary. Like I said before, the output of the sector can be consumed or demanded by other sectors that produces. For example, agricultural products or output uh, will be used by manufacturing sector by the manufacturing sector. These are called intermediate demands. Okay, so this is the output of the sector that goes to other sectors. This is called intermediate demands. And the part of the output that is demanded by households, the government, and the rest of the world through exports are called final demand. So we have intermediate demand and final demand. So those are the two types of demands in this model. And so the output in certain sectors is used is produced by using inputs And there are two types of inputs in this model. First are intermediate inputs. These are inputs coming from the other producing sectors. Okay, so these are called intermediate inputs. And so a machine coming from the manufacturing sector, which will be used as inputs to produce goods in the agricultural sector, for example. These are called intermediate inputs. And there are also other types of inputs, such as labor, capital, and imported goods, which are called primary inputs. So there's a distinction between these two types of inputs: primary inputs and intermediate inputs. So in this slide is an example of a transactions or an IO table. So here we have the different producing sectors: agricultural, mining, construction, manufacturing, trade, transport, services, and others. Okay, and so the output from these producers goes to the different sectors. By the way, agri can use inputs from or outputs from its own, right? So the output can go through these different sectors, or it can go to households. PCE here means personal consumption expenditure. This is household, this is government, okay? And this is the rest of the world through exports and others, okay? So in the next slide, you have an example of a three sector IO table. So entries here are actual amounts in billions of pesos. This is from 1994. So agriculture here, okay, agriculture here. The output 44.7 billion is demanded by the sector itself. 214.5 billion is demanded by industry, and 15.8 is demanded by services. Now, final demand for household, uh, government, and the rest of the world is 197.3 billion. So in total, agriculture produced a total output of 472.3 billion. Okay, so notice that this total output is the same as this total input. So the total input from agriculture is 44.7 billion. The intermediate input of agriculture to industry is 42.8, and to services is 28.6. And the primary inputs, the total labor, capital, and imported inputs for agriculture is 356.1 billion dollars. So for a total of 472.3. Okay, so there's a correspondence between the inputs and the output, the total input and the total output. Now, based from the input output table, we can compute for the technical coefficients. Now, the technical coefficients are obtained by dividing the column values to total output. Okay, so in this case, this is the same as we had earlier. So these are the different values in the table. So look at this column first. Okay, so when you divide, so this is total output, this is the amount of primary inputs, agriculture, industry, and services. So when we divide 44.7 to the total output in agriculture, which is 472.3, you get 0.095. 42.8 divided by 472.3 is 0.091. 28.6 divided by 472.3 is zero point zero 0.06. And 356.1 divided by 472.3 is 0.754. So notice that the sum of this amounts in this column, they all sum up to 1. Okay, so 1 here is the fact that 472.3 divided by itself equals to 1. So they sum to 1. So what? So you do the same for this column. Okay, so you divide this entry by this entry to get this entry over here, and so on and so forth. Okay. Now, what do these numbers mean? Okay, let's take this first set of numbers here. So the technical coefficients is said to show the unit cost structure of production. Okay, so it shows what the requirement of input is per unit of output. So for each unit of output, so for 1 unit of output, what's a percentage of inputs that's coming from agriculture, industry, services. So in this case, 9.5% of the output is produced for by agriculture. Okay, I mean 9.5% of output in agriculture is produced by the sector itself. 9.1% is by industry. 6% is by services, and 75% of the output is produced for by primary inputs, labor capital, and imported goods. So these are what's called the technical coefficients. Okay, so this coefficients, this entry shows the proportion of inputs per unit of output in the same column. Okay, in this case, agriculture. Here it's for industry. Here it's for services. Now we can collect the numbers inside the cells of intermediate inputs and intermediate demands. This part over here, and let's call it matrix A. Okay, let's write it as a matrix so we can write it as such. This is called the matrix of technical coefficients. So here, this 0.095 is is entry A11. This one is entry 0.167 is entry A12. 0.01 is A13, and so on and so forth. Okay, so this is how you get the matrix of technical coefficients. Now here's a general input-output table. So instead of numbers here, we have symbols. Uh, and the entries of this table are as such. So X11 over here is the output, for example, of sector 1, which is agriculture to agriculture. Okay, X12 over here is the output from agriculture supplied to industry, the second sector, and so on and so forth. So we have X13 over here, and D1 over here is the final demand. Okay, so X1 is the total output of sector 1, which is agriculture. So we have x1 equals to x11 plus x12 plus x13 plus d1. Okay, and so on and so forth. It's the same for this row over here. X21 uh, is the amount of output in sector 2, which is industry, that goes to uh, agriculture. And x22 is the amount of output in industry that goes to industry. And X23 is the amount of output in industry that is supplied to the services sector. This is the amount of final demand for industry, and this is the total output of industry of sector 2. Okay, so this is what these entries are in this table. Now Z1 over here is the amount of primary inputs of agriculture. Z2 is the primary inputs in industry, and Z3 is the primary input in services. Now let's just zoom in this part of the table that we had in the previous slide. So we have discussed what this amounts are. So X11, just to recall, is the amount of output in agriculture supplied to agriculture. X12 is the amount of output in agriculture that's supplied to uh, industry, and so on and so forth. Now, this last uh, row over here is total output. Okay, so X1 is the output, total output in agriculture. X2 is the total output in industry, and X3 is the total output in services. Now let's do this. If we divide X11 divided by the total output, we will have the value or entry A11 in this table. What is A11? Like we discussed about 2 slides ago, these are the technical coefficients. Okay, the amounts here are technical coefficients where we divide this entry over here with total output for this column. Okay, so here we divide x11 by x1, that's A11. A21 is divided by x21 by x1, and A31 is dividing x31 by x1. Okay, so this is for agriculture. These are the technical coefficients for agriculture. For industry, you divide x12 by the total output of industry, so you'll get A12. Okay, x22 divided by total output is A22, so that's a technical coefficient of industry, and A32 is x32 divided by x2. Okay, so again, what's the concept of technical coefficients? It's the unit cost of production. So the part of percentage of inputs needed to produce a unit worth of output. Okay, so a peso worth of output. So those are the technical coefficients obtained by dividing the entries in the column by the total output in the column. Okay. Now this left table is the same as before. This is how we obtained how we computed the technical coefficients. So this is the same as previous slide. Now notice that you can recover the entry x11 by multiplying A11 with the total output of sector 1. Okay, so you can recover x11 by multiplying A11 with x1, x21 by multiplying A21 with x1, okay, and so on and so forth. So what we did is simply just to move the total outputs to the left hand side. Okay, so we cross multiplied it. So we obtain or we recover these entries over here. Okay. Okay, so first let's see this. There's lots of things here, but recall that this table over here is the same as the previous slide, where we recovered the entries x11, x12, and x13 by multiplying the technical coefficients with the total outputs for the respective sectors. Okay, and if you look at this table, which is the input and output table, we know that total output for agriculture is just the sum of outputs supplied to the different sectors, x11, x12, x13, plus final demand is equal to the total output. So this is this relationship over here. Okay, so x1, the total output, is just the sum of the output supplied by sector 1 to the different sectors 1, 2, and 3, as well as to households, governments, and the rest of the world, which constitutes final demand, D1, the final demand for sector 1. Okay, so we can rewrite each of these entries x11, x12, x13 by this, okay, in this table. So x11 over here is A11 times x1. So we can write the first equation as x11 equal to A11 x1 plus A12 times x2 plus A13 times x3 plus D1. Okay, the second equation over here we can write as x2 is equal to A21 x1 plus A22 x2 plus A23 x3 plus D2. Okay, and finally the third equation over here, x3 can be rewritten as A31, this one, A31 x1 plus A32 x2 plus A33 x3 plus D3. Okay, so notice that you have uh, the vector of technical coefficients here, I mean the amount of technical coefficients here, as well as x1, x2, and x3 here, okay, and d1 and d2 and d3. So what's the bottom line of this one? Well, you can write this down in matrix form. So now we've rewritten on the upper right portion of this slide the three equations that we had on this previous slide. Um, this equation over here. Okay, oh, sorry, this equations over here. So just rewritten that um, using this one, and notice that you can write these three equations uh, in matrix form. Okay, so we can rewrite it as the equation x equals to ax plus d, which is called the Leontief equation. Okay, so x over here is equal to x1, x2, x3. The matrix A is equal to a11, a12, a13, a21, a22, a23, a31, a32, a33. Okay, and then the vector D is equal to d1, d2, and d3. Okay, so again, if you multiply A with x, so the first equation here, for instance, you can recover this part. You can recover this part by doing the inner product of this first row with x. Okay, so a11x1 plus a12x2 plus a13x3 is exactly this one. So the second equation over here, this part is obtained by by getting the inner product of the second row of a and x. Okay, so and so on and so forth. So you can represent this three equations into this in matrix form into this equation, which is called the Leontief equation. So A is the technical coefficient matrix, or the input output coefficient matrix. X is the vector of outputs, 1, 2, 3. In this case, we have agriculture, industry, and services. And D is the vector of final demands accruing to each of the sectors respectively, D1, D2, D3. Okay, so solving for the Leontief equation, uh, x equals to ax plus d, means that if we have a technical coefficient matrix A, and the final vector of the vector of final demands D, what is the level of x that would satisfy both intermediate and final demands? So solving this one looks for the equilibrium values of x. Okay, so this means that we have to find that vector x that will satisfy this equation. Now let's start with the Leontief equation. This a equals to ax plus d. Again, in the end, we want to find the equilibrium vector of x. Okay. So here in the second bullet point, this is just the fact that we added I, the identity matrix, because anything multiplied by the identity matrix is the matrix itself. In this case, if you pre-multiply I by the vector x, you'll obtain x. Okay, you'll recover x. And then what we did was to transfer uh, ax to the left-hand side. That's why there's the negative ax over here. So you have ix minus ax equals to d. D is left on the right-hand side. Okay, so we can isolate x, and we have I minus a. Okay, and this is equal to d. Now this is a special matrix. So when you subtract from the identity matrix the technical coefficient matrix, this is called the Leontief matrix. Okay, so in this case, how do you solve for the vector x? Okay, so solving for the vector x, simply requires that I minus a should have an inverse, right? So I minus a inverse times d is the way to get the vector x, okay? So that's the first question. Does this inverse exist? Because if this inverse exists and it's unique, then the vector x will be unique, okay? So there's a solution to this one. But there's a second point. So this solution must be non-negative because it's hard to think of outputs that are negative. What's a negative output? You're giving it away. Yeah, it only has to be only positive or zero output will be admitted as a solution to this equation. Okay, so we need to find whether this has an inverse, the Leontief matrix has an inverse, and the solution will be non-negative.